Parts of a drone and drone controller. Drones, also known as unmanned aircraft systems (UAS), have gained immense popularity in various fields, from photography and videography to working on our farms, from helping the logistics sector to recreational flying. The possibilities for these machines are endless. And so, for drone technical specialists, it is essential to familiarize ourselves with their key components. From the powerful motors and propellers that generate lift to the sophisticated flight controllers and GPS systems that ensure stability and navigation, the parts of a drone come together to create a seamless and exhilarating flight experience. In this video, we will explore the different components that make up a drone, unraveling the inner workings of these modern marvels of technology. Parts of a drone. The frame is the structural backbone of the drone, providing support and housing for all the other components. It is typically made of lightweight materials like carbon fiber or plastic to maximize flight efficiency. Drones have multiple electric motors, usually 4 or more, attached to the frame. They are the powerhouse of the drone, providing thrust to its various parts like propellers, camera and gimbals, landing gear. Typically, brush motors are utilized in smaller drones, whereas brushless motors are used in large drones and UAVs. Each motor is connected to a propeller. When the motor spins, it provides the thrust and lift that enables the drone to fly. The size and pitch of the propellers affect the drone's performance, such as its speed and maneuverability. The brain of the drone, the flight controller, is a small onboard computer that manages its stability, navigation, and response to user inputs that it receives from the receiver, GPS module, battery monitor, and onboard sensors. It calculates the appropriate motor speeds and control signals to stabilize the drone and perform desired maneuvers. It is in charge of all commands, including camera triggering, autopilot mode control, and other autonomous operations. The battery provides electrical energy to the motors, flight controller, and other electronic components. The flight time of a drone is dependent on the battery's capacity. The battery requirements for drones depends upon the size of the drones. Drones are powered by rechargeable batteries, usually lithium polymer (LiPo) batteries, because they offer the best combination of performance, weight, and cost. On the drone, there is a battery monitor that lets the pilot monitor the battery's performance by displaying battery information. Each motor is connected to the electronic speed controller. The electronic speed controller, ESCAPE, is an electric circuit that receives inputs from the flight controller to adjust the motor speed, maneuver the drone's direction, and control its brakes. These controllers regulate the precise control of the drone's movement. For all of their flight demands and performance, modern drones rely totally on the ESCAPE. The receiver receives commands from the transmitter or drone controller and translates them into actions. The minimum amount of channels required to operate a drone is generally 4. The transmitter, also known as the remote controller, allows you to pilot the drone. The transmitter is in charge of transferring radio signals from the controller to the drone's receiver in order to issue flight and navigation commands. To communicate with the drone while in flight, the receiver and transmitter must use a single radio signal. Each radio broadcast has a unique code that allows it to be distinguished from other radio signals in the air. Modern drones are equipped with many sensors to gather data about their environment and flight parameters. These sensors can be obstacle avoidance sensors that enhance the drone's safety by detecting and avoiding potential collisions. The GPS module, which enables accurate positioning and navigation of the drone. Drones would not be as essential as they are now if not for the GPS module. This component assists the drone in navigating longer distances and capturing specific details of land areas. Even without the use of the flight controller, the GPS module aids in securely returning the drone home. In most current drones, the GPS module helps in the safe return of the drone to the controller if it loses contact with it. This contributes to the drone's safety. Capturing stunning aerial footage is one of the main attractions of drone technology. Some drones feature a built-in camera, while others have a camera that can be detached. The gimbal stabilizes the camera and minimizes vibrations during flight, ensuring smooth and steady footage. The landing gear ensures a stable touchdown during takeoff and landing. However, the landing gear is not required for all drones. Some smaller drones can fly without landing gear and land safely on their stomachs once they make contact with the ground. Now that we are familiar with the drone's components, let's shift our focus to the drone controller, the interface between you and your flying machine. Parts of a drone controller. Main functions of a drone controller. Understanding the four main functions of the drone controller is essential for precise flight control and executing aerial maneuvers. Let's dive in. Yaw refers to a clockwise or counterclockwise rotation of the drone. Throttle. The throttle controls the amount of power sent to the drone's motors, allowing for faster or slower flight speeds. Roll refers to the left or right movement of a drone. Pitch refers to the lift of a drone, either forward or backwards. The right and left stick lets you operate these commands. Right stick. The right stick lets one control the roll and pitch of the drone, allowing one to move the drone right-left as well as forward and backward. Left stick. The left stick lets one control the yaw and throttle of the drone, allowing one to control the height at which one flies the drone and length one rotates the drone clockwise or counterclockwise in flight. Drones have become an indispensable tool across industries, offering limitless possibilities for aerial exploration. By understanding and mastering the components that power these machines, such as motors, propellers, flight controllers, sensors, and cameras, we unlock their full potential. Let's embrace the marvels of drone technology and continue pushing the boundaries of what they can achieve in the skies above.